So today in section 4.5, we're dealing with quadratic equations. They have the standard form of ax squared plus bx plus c equal to 0. We've seen that before. Other than the equal to 0 part, we've seen that ax squared plus bx plus c, right? That was trinomials that we've been factoring here the last 4 days. They were always in that type of form. Okay? So, before we get into how we do this, I want to talk about kind of why we do this. Okay? Why we do this. Well, when we're solving this, and don't worry about this f of x stuff right now, this fx, we'll talk about that later on. That's called function notation. Okay? Anytime you see f of x in your work, sometimes it might show up in the book when you guys get books next week, or show up in your notes or things like that. Just know right now that this just means y. Okay? Later on, we'll talk more about what that actually means, but for right now, anytime you see that fx like that, it's just a y. Okay? So, what we're looking for is we are looking for, if we have an equation, y equals ax squared plus bx plus c, that equation, if we graph it, is not a line. Okay? In Algebra 1, you guys drew or graphed a lot of lines. Well, we're no longer graphing lines in here. And we're not going to be graphing right now. I'm just kind of giving you a foreshadowing what's coming up. But a quadratic equation graphs what's called a parabola. It's like a U-shaped graph. Okay? And if we have it set equal to 0, that means we're solving for where that graph crosses the x-axis. Those points right there are called the zeros of a function, or the zeros of an equation. And the reason I'm pointing that out is because that right there, that phrase, find the zeros of this equation, or find the zeros of this function, that phrase tends to show up in the state NISA exam that you guys, all your juniors will be taking this year. It shows up sometimes in the ACT that those of you wanting to go out into a four-year college will have to take, or the SAT, those of you wanting to go to a four-year college on the coasts. The East and West Coast tend to use the ACT rather than the ACT, or the SAT rather than the ACT. So that phrase comes about. That's what they mean. Find the zeros. It means take that equation, set it equal to 0, and solve for x. Okay? So how do we do that? Well, there's another property we're going to use to solve for x. The property is called the zero product property. Product in math means multiplication, okay? And so this is kind of saying the zero multiplication property, which is if you have two things multiplied together, if A times B equals 0, and those two things can be anything. You can think two numbers, you can think two binomials, you can think whatever. If you have two things multiplied together and that equals 0, that means that then one of those two things must equal 0. Does that make sense? Let's think about that for a second. If we have two numbers, and I know that they multiply together to equal 0, tell me, does that not make sense then that one of those two numbers has to be 0? Right? Isn't that the only way you can get 0 by multiplication? Is if I take a number times 0, then I get 0. Or if I take 0 times 0, I get 0. Right? So if these two things multiplied gives me 0, then one of them must equal 0. That's what we're saying here. Okay? So how are we going to use that? Well, that comes down here to example number 1 in our notes. We have a quadratic equation. It's written in the form ax squared plus bx plus c. And you always want it written in standard form. You never want to mix it around or things like that. The x squared term always comes first. The x term always comes second. The constant term always goes third. And then we want it set equal to 0 right now. Okay? Well, we want to rewrite this so that it's two things multiplied together. So, we've got to factor that trinomial. There's no GCF, so we go straight to the x method. 1 times negative 30. Negative 1 goes down below. So what are two numbers that multiply to give us negative 30 but add together to give us negative 1? First off, what do you know about the signs of those two numbers?
1
One's negative, one's positive. Yep.
-6 and 5.
Perfect. -6 and +5. Multiply to -30, but add to -1. So just like we've been doing the last 4 days, we use those two numbers to break apart that middle term. So we now have x squared minus 6x plus 5x minus 30. But now we have that equals 0. That equation has to follow along here. Okay, that whole expression equals 0. We're only working with the left side. All right, so we want to factor now that left side, which we do exactly like we've been doing the last few days. We now need to factor by grouping. My first group, and by the way, if you feel comfortable with this now, go ahead and work ahead. See if you come up with the same answer after we factor. Okay, if you're still struggling, kind of shoot your eyes up here and make sure that you are following along. So, in that first group, I can factor out an x. I'm left with x minus 6. In the second group, I can factor out a positive 5. Leaves me with x minus 6. And now my last thing is I can factor out the x minus 6. Which leaves me with an x plus 5. Okay? So we have factored that trinomial. Now we have rewritten the trinomial so that we have two things multiplied together and it equals 0. So here's where the zero product property comes into play. I want to go ahead and break apart this equation. I want to say that either the first thing equals 0 or the second thing equals 0. So either x minus 6 equals 0 or x plus 5 equals 0. Well, if x minus 6 equals 0, we can solve that by adding 6 to both sides, remembering our algebra skills. So x equals a positive 6. And if x plus 5 equals 0, we're going to subtract 5 from both sides. Again, using our algebra skills. So then x equals negative 5. And there's our two answers. Okay, that right there is all we're doing today. I want to show you one more thing, just kind of foreshadowing what's going on. When I say, if the ACT or the NISA or something like that says find the zeros, and we do this, what does that actually mean? Why do they call it find the zeros? Why do they not just say solve for x? Well, because technically, this equation represents the graph of a parabola, which is a big U-shaped graph. And what we just found are where that graph crosses the x-axis. It crosses the x-axis at negative 5 and positive 6. That's what we've solved for. That's why they call this finding the zeros. Okay? Because we're finding the x values where y equals 0. Okay? So let's take a look at number 5 next. Number 5, we don't have a trinomial here anymore. Oh no. Okay? But it's still a quadratic equation because if I wanted to, I could still say that this is 4x squared plus 0x minus 100. I could still write that in that standard form if I wanted to. I wouldn't if I were you. Some of you are recognizing this as a what? Difference of squares. This is a difference of squares. But before we work difference of squares, we should be looking for a what? What is always rule 1? Rule 1 is always GCF. So is there a GCF?
Yeah.
Bigger. 4. Left with x squared minus 25. Now we want to factor this difference of squares, x squared minus 25. So remember, we think of that as what squared minus what squared. So x goes in the first set of parentheses and 5 goes in the second set of parentheses. So now we have 4 times our two binomials, because that's what the pattern always said. One of them is a plus, one of them is a minus. And we get x plus 5, x minus 5. And don't forget, yes, you got to keep that equal sign coming along because we're solving an equation. Okay? So, there is our factored form. But now notice we have three things multiplied together now, right? Three things multiplied together to equal 0. Well, that's just an extension of the zero product property. Because if two things multiply together to equal 0, so one of them must be 0, wouldn't that hold true that if three things multiply together equal 0, then one of those must equal 0? Or four things, or five things, or six things? Right? It doesn't have to be just two things multiplied together. It could be 15 things multiplied together equal 0. One of them must equal 0. Right? So all we do here is break it apart into three little equations. 4 equals 0, x plus 5 equals 0, x minus 5 equals 0. Well, our first question is, does 4 equal 0?
No.
No. No, it doesn't. Never has. So that's just a bad answer. It's a wrong answer. 4 does not equal 0. Cross it out. Okay? Well, now we go to the next one. X plus 5 equals 0. Well, we must subtract 5 from both sides. So x equals negative 5. Our next little equation, x minus 5 equals 0. Add 5 to both sides. X equals 5. There's our two answers.
So do we just leave 4 out of the answer then?
Yeah, 4 is not an answer, because 4 does not equal 0. Okay? So 4 is not an answer. It does not equal 0, so we cross it out. Our only answers are negative 5 and positive 5. What if you wanted to check your answers? What would you do?
Plug it back in.
Plug it back in. You would take negative 5 and plug it into the original any place you see an x. And you would work it out and see if it works, right? What if I want to check the positive 5? Well, again, I plug that positive 5 up in the original any place I see an x and see if it works, okay? All right, so looking at number 8 in your notes, notice this is not written in standard form. Okay? This is not written in standard form, so therefore the first thing we need to do is write it in standard form. We need to have it equal to 0. So, what I want to do is I want to subtract 4 from both sides and add x to both sides. Now please remember, we're breaking this apart, right? Remember drawing that line down the equal sign in Algebra 1? Make sure you're doing things to the left side and right side of the equation. So please keep that in mind. You can only do opposite operations like this if you're doing it on both sides of the equal sign. Okay? So then minus x plus x cancels away. Positive 4 minus 4 cancels away. Over here I need to combine my like terms. X squareds go with x squareds. X's go with x's. Constants or just numbers go with numbers. So I now have 4x squared minus 13x plus 3 equals 0. Now it's in standard form, so now I can solve it by factoring. Is there a GCF? No. So then we go to the x. 4 times 3 is 12. Negative 13 is our b. Okay, I know we need two negative numbers because they multiply to become positive, but add to be negative. And then yes, 12 and 1 are going to be those two numbers. So, just like before, we take those two numbers to break apart the middle term. So we have 4x squared minus 12x minus 1x plus 3 equals 0. And we solve by grouping. The first two together, I need to make sure that negative comes along with the x. So I'll make it plus a negative x, and then group that together. In my first group, I can factor out 4x. Leaves me with x minus 3. In my second group, what am I factoring out? a negative 1. And that leaves me with x minus 3. And so now I can factor out the x minus 3. Okay? We have our two things multiplied together that equals 0. So we go through and break it apart. And we say that x minus 3 must equal 0, and 4x minus 1 must equal 0. So I add 3 to both sides. X equals 3. On the other one, what do I have to do first? I first add 1 to both sides. I get 4x equals 1. Now I divide by 4, so x equals 1/4. There's our two answers. So, in number 9 here, do we have it in standard form? No, so we need to put it in standard form. Okay? Some of you might be thinking, well, let's just subtract x squared. And that's fine. It'll work. The problem is, remember I said over the last 4 or 5 days, I never want my x squared term to be negative. That first term, I always want it to be positive. Otherwise, we have to factor out a negative 1, right? I don't want to factor out a negative 1. So just make your life a little bit easier and just leave the x squared positive. So that means rather than subtracting x squared, what do I need to do? Add the 2x to both sides and subtract 1 from both sides. Minus 2x goes away, plus 1 goes away. And now, do I have any like terms over there on the left side? No. Remember, x squareds go with x squareds. X's go with x's. Numbers go with numbers. I don't have any two of the same, so I just write this out as x squared plus 2x minus 1. Make sure you write it in standard form. The x squared term first, the x term second, the constant third. Because that's the way we're used to seeing it. That is standard form. Okay, so next, we want to try to factor that. So we go ahead and we draw our x, because there's no common factor. We got to take 1 times negative 1, and 2 goes down below. We're looking for two numbers that multiply to give us negative 1, but add to 2.
Two negatives.
Nope, because there has to be one positive and one negative, right, to get the negative answer when we multiply. What numbers multiply to 1? 1 and 1. Can 1 and 1 ever equal positive 2 if one of them has to be negative?
No, never.
No.
No. Man. Not factorable. Numbers is what I'm looking for. Okay? And actually, there are real numbers. I'm actually lying here by saying no real numbers. Actually, what I mean is integer solutions. There are no integer. For right now, if you guys just put no solutions, I'm happy with that. I'll explain more of how we're actually getting these solutions. So if you put no solutions or can't factor, I'm happy with that answer. Okay? Because you can't solve this by factoring, because that trinomial does not factor. Not with nice numbers anyways. It might factor with square roots. It might factor with things like that, but we're not going to go there. Okay? There is a way to factor it. There is a way to solve it. We're not there yet. Today we're only focusing on solving by factoring. So if you can't factor, today you can't solve it. Okay? Okay? All right.